Hello children, this is our mathematics class and we are doing chapter number 13, surface areas and volumes. In the last video lesson, we have completed exercise 13.2 and today we are going to begin with exercise 13.3, and this exercise is based on converting the solid from one shape to other shape. So let's begin with the exercise and we will start with question number 3. The question is, a 20-meter deep well with diameter 7 meter is dug and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. Now just understand which shape we are converting into which other form. So a 20-meter deep well is dug and the earth from the digging is arranged or put in the form of a platform. So cylindrical well gets converted into cuboidal platform. So just the change of shape. Let's draw the diagram first so that you will understand the sum better. So a cylindrical well with 20 meter deep, that is the height given to us. The diameter of the well is given as 7 meter and the earth from the digging is evenly spread out to form a platform. Length of the platform is 22 meter, breadth is 14 meter, and we have to find the height of the platform. Now the sum is very clear, right? So we can make our formula that the volume of the well and the volume of the platform is same. Well is cylindrical in shape, platform is cuboidal in shape. So volume of well is equal to volume of cuboid. So let's calculate the volumes one by one. Let's first calculate volume of cylinder. So to calculate volume of cylinder, we need radius of cylinder. We are given the diameter as 7 meter. So radius is equal to 7 upon 2 meter. We are also given the height of the cylinder, that is 20 meter. So I know you can recollect the formula now. Volume of cylinder is pi r square h. Let us substitute the values into the formula. So 22 by 7 into 7 upon 2 the whole square into 20. Let's simplify this. 22 by 7 into 7 upon 2 into 7 upon 2 into 20. Alright, I hope children you all are writing along with me. Now just check out what all terms you can cancel. So cancel out this 7, 7. You can cancel 2 11s are 22. Then we can cancel 2 10s are 20. You can write 11 into 7 into 10 and that is equal to 770 meter cube. So volume of cylinder we have calculated. Let's calculate the volume of cuboid now. We are given the length, we are given the breadth and height we have to find out. Volume of cuboid is L into B into H. Let's substitute the values. 22 into 14 into H. So now we have both the values, volume of cylinder and volume of cuboid. Let's equate the values, and after equating the values we get 770 is equal to 14 into H. So now let's find out the value of H, and for that we will write 770 upon 22 into 14. Now you can check out what all things you can cancel. We can cancel 11 2s are 22, 11 7s are 77 and 0 as it is. Then we can also cancel 7 2s are 14 and 7 1s are 7, 7 zeros are 0. We are left with 10 upon 4. 10 upon 4 is 5 by 2 and 5 by 2 is 2.5 meter. So the height of the platform is 2.5 meter. Alright, so the type is only different, otherwise all formulas, everything is same. One shape we are converting into the other shape and the volume remains the same. So let's move to the next sum. This is question number 4, and let's see what is the sum. So question number 4 is, a well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. Alright, when we make the figure, we will understand the sum more better. So let's try making the figure first. A well of diameter 3 meter. A well, so must be cylindrical in shape. Its diameter is 3 meter and 14 meter deep, means height is given to us. Now, what the sum says is, the earth taken out from it has been spread evenly around it in the shape of a circular ring. So let's see what shape we get. We have a cylinder like this. This is our original cylinder with diameter 3 centimeter. But the earth taken out by digging this well is arranged evenly around this well in the shape of a circular ring like this. The width of the ring is given to us as 4 meter. And this ring form an embankment around the well. We have to find this height of embankment. So both well and the embankment are in the shape of a cylinder. If you see, children, their volume will remain the same. Let's mark the well as cylinder A and the embankment as cylinder B. And let's try finding the volume of both cylinder A and cylinder B. Then we will equate the volumes and then we'll be able to find the height of embankment. So let's do that. Since the mud of the well is distributed in the embankment, just now I said volume of well and volume of embankment will be same. So let's start finding volume of a well. Now to find volume of a well, we know that it's in the shape of a cylinder. We need a radius. We are given diameter as 3 meter. So radius is 3 by 2 meter and 3 by 2 meter is 1.5 meter. We are given the height of the cylinder as 14 meter and volume of the cylinder, yes, I know you could recollect that, it is pi r square h. Let's start substituting the values. So pi into radius is 1.5 the whole square into 14 is the height. Let's simplify this. Pi into 15 square is 225. Since it is 1.5 the whole square, so we'll get the value as 2.25 into 14 is the height. So we get 31.5 pi meter cube. We have kept pi as it is for the sake of convenience in calculations. So we got volume of well as 31.5 pi meter cube. Alright, so volume of well is volume of cylinder, which will be 31.5 pi meter cube. Now let's find volume of embankment. Now this cylinder B, it is a hollow cylinder with inner diameter is equal to the diameter of the well, and we have written that the diameter of the well is 3 meter. Now let's first understand what is the internal radius. Now inner diameter is 3 meter. So the internal or the inner radius is this, and we will show that by R1. So R1 is equal to 3 upon 2, which is equal to 1.5 meter. Now let's find out the external radius. Now what will be the external radius? It is the internal radius, this. Please look at the figure, children. Internal radius and the width of the embankment is given to us, that is 4 meter. So total external radius will be internal radius plus width. Internal radius is 1.5, width is 4, and that is equal to 5.5 meter. So we have calculated the internal radius, we have calculated the external radius. So let's now find the volume of the cylinder with internal radius. And with internal radius, our formula is equal to pi r1 square h. Right? So substitute the values. Pi h we will write as it is. R1 square is 1.5 the whole square. And the volume of cylinder with external radius is equal to pi r2 square h. So pi as it is, h as it is, and r2, the external radius, is equal to 5.5 the whole square. Alright. So now volume of cylinder B is equal to volume of the cylinder with external radius minus volume of cylinder with internal radius. Alright, so the volume of embankment we are finding, it will be equal to volume of cylinder with external radius minus volume of cylinder with internal radius. So volume of cylinder B, we will write the values now. We got the values. The volume with external radius as pi h 5.5 the whole square minus pi h 1.5 the whole square. So let's take this pi h common. So in the bracket we are left with 5.5 the whole square minus 1.5 the whole square. Alright. So we are left with pi h 5.5 the whole square is 30.25 minus 1.5 the whole square is 2.25. Subtract these two values and your answer is pi h into 28. So 28 pi h meter cube is volume of cylinder B, and cylinder B is the embankment. So volume of embankment is 28 pi h meter cube. Alright, but what we have to find out? We have to find out the height of the embankment. So we have calculated volume of well, we have calculated volume of embankment. Let's equate that. So 31.5 pi is equal to 28 pi h. Cancel out this pi. So we are left with h is equal to 31.5 upon 28, and if you calculate this, your answer is 1.125 meter. So the height of embankment is equal to 1.125 meter. Alright, so I hope you understood the sum, and let's move to the next sum now. So this is question number 6. How many silver coins 1.75 centimeter in diameter and of thickness 2 mm must be melted to form a cuboid of dimensions 5.5 centimeter by 10 centimeter by 3.5 centimeter? So number of silver coins, we have to find out how many silver coins must be melted so that we get a cuboid of the dimensions 5.5 by 10 by 3.5 centimeter. So let's try drawing the solid figures first. So a coin with diameter 1.75 centimeter, thickness is also given to us as 2 mm, and thickness is the height of the coin, that is 2 mm. Now how many such coins will melt so that we get a cuboid like this with length 5.5, breadth 10 centimeter and height 3.5 centimeter. Now to find number of coins, we'll make use of the formula volume of cuboid upon volume of one coin. This formula will give us number of coins which should be melted. So let's find out the volumes one by one. Let's first find volume of a cuboid. For that we need length, breadth and height, which is already given to us. So volume of cuboid is equal to L into B into H. Let's substitute the values. So 5.5 into 10 into 3.5. If you multiply these three terms, we get 192.5 centimeter cube. This is volume of cuboid. Let's find volume of one coin now. To find volume of a coin, we need radius. We are given the diameter of the coin as 1.75. So its radius is 1.75 upon 2 centimeter. That is 0.875 centimeter. Let's take out the decimal point. So it is 875 upon 1070 centimeter. Then we are also given height, that is 2 millimeter, but we have to convert this 2 millimeter into centimeter because all other values are in centimeter. So 2 millimeter is equal to 2 into 1 upon 10 centimeter, that is 2 by 10 centimeter. Okay, so to find volume of a coin which is in the shape of cylinder, our formula is pi r square h. Let's substitute the values. So 22 upon 7 into 875 upon 1000 the whole square into 2 upon 10. If we simplify this, it is 22 upon 7 into 875 upon 1000 into 875 upon 1000 into 0.2. Now you can cancel out this by 25. Just you have to do the calculations, and once it is done, you'll get the value as 0.48125 centimeter cube, which is volume of one coin. Now we can find out number of coins because we have got volume of cuboid and volume of one coin. Let us substitute the values into our formula. So volume of cuboid is 192.5 upon volume of one coin is 0.48125. Let's take out the decimal point from the numerator. So our value will be 1925 upon 4.8125. Let's now take out the decimal point from the denominator as well. And so if we take out the decimal point from the denominator, those many zeros will go to the numerator and we'll get the value as 1925,0000 upon 48125. You can again reduce this to the lower term and we'll get the answer as 400. Therefore, number of coins which should be melted to get a cuboid is equal to 400. Alright. So along with this, children, I have an assignment for you all. Since we started with question number 3 from the exercise, question number 1 and 2 is for your homework. These are simple sums. If you read, you can make out and you can find the answer. We also left question number 5 and that is also for your homework. You will try doing question number 5 as well. So do these 3 sums and in the next period we will solve few more sums. Till then, bye and take care.